is LeetCode 83, which is remove duplicates from sorted list. Okay, so the problem or the question given is that we are given a head of a sorted linked list, and we have to delete all the duplicates such that each element appears only once, and we have to return the linked list in the sorted manner which was given in the first place. So the constraints are 0 to 300, that is number of nodes, and values are from negative 100 to positive 100, and sorted order, and it is in the sorted order. Okay. Uh, Now, for example, this is one linked to another node with value 1, linked with another node with value 2. Now, one is a recurring number which is coming twice. So we have to eliminate one of the ones. So the output should be 1 linked to 2. So here the second one was removed. Similarly, if it's an empty linked list, the output should also be empty. So since there is nothing to remove. The next one is, so the approach we are going to use is slow and fast pointers. Yes, you might have heard it before. This approach is also used to identify whether the linked list is cyclic or not. Okay, so the same approach will be applying for the removing duplicates question. So here, sorry for the overlapping. So this is the linked list given 1, 1, 2, 3, and 3, and then null, which is not pointing to anything. So we will be starting with the first node, which is pointed by the slow pointer, and the next one, the next immediate node to the slow pointer would be pointed by the fast pointer. Okay, so the fast pointer travels one step ahead to the slow, so that is two steps ahead. Okay, now after after traveling, the slow pointer is used to remove the duplicates. Okay, so this, when the slow pointer is here and the fast pointer is here, it will check whether a slow pointer value is equal to the fast pointer's value. So if that is so, it will just delete that, and the fast pointer will move ahead, and the slow pointer would stay at the same place. The next thing is, uh, after the fast pointer does that, we'll check again, and if it is not equal, then the fast pointer will go to the second next node, and if it is equal, it just deletes the slow pointer, just makes the node deleted. Okay, so the output would be 1, 2, and 3, and this is O of 1. With O of 1 extra space, we won't use anything. We can also use hash set for that reason. uh, we can first traverse the linked list and put all the elements into the hash set, and but the thing is, the numbers stored in hash set are uh, not in a sorted order. So when you try to create another linked list and put all the elements in the hash set, you must be sure that everything is in order. So that was the hash set approach. Now this is the Java code. Okay, this is the two pointer in place approach. So let us start coding. The first condition we should be uh, considering or taking care about is that if head is null, if head does not, if there is no linked list, or if there is a linked list but there is only one node, then we have to either return the empty linked list or just return the node, which can be returned which can be written as head is equal to null, or head dot next is equal to null. Okay, and then return head. Okay, the next thing is we'll create two pointers, which is slow and fast, as you have seen in the PDF. List node slow, and this will be starting from the head, as you have seen. Okay, and then list node. See, list node is already has been defined in the LeetCode. Uh, what do you say? IDE. Yes, LeetCode IDE. It's defined as int value, which stands for value, and list node next, which points to the next node if there is any. And uh, when you call this class, the value that you pass, sorry, the value that you pass will become the current value for that node. Okay, that's what this line says. Then list node slow is head, we'll start slow pointer from the head, and then list node fast is equal to head dot next. We'll be starting the fast pointer from the next node of slow pointer. Okay, so then we'll be traversing, since fast is ahead of slow. Okay, fast pointer is ahead of slow. We'll check whether fast is equal to null or not equal to null. If it is equal to null, then we'll just stop. If it's not, we'll just move. Okay, and slow pointer will never reach the end, because although it reaches the end node, but it will not go, even if it goes to null, the uh, while loop will already be we come out of the loop already. Okay, so there is no need to worry about whether slow pointer would be null or not. Okay, and then in this while traversing, we'll check whether if slow pointer's value is not equal to fast pointer's value. Okay, and then if it is the case, then we'll just traverse with the slow pointer also. We'll just make the slow pointer go to the position of fast pointer, sorry, point to the node of fast pointer, and then we'll make slow pointer go to the fast pointer's position. First, we'll make the slow pointer's node point to the fast pointer's node, and then make the slow pointer go to the position of fast pointer. Okay, and then if it is not the case, then we'll just make a fast pointer go to the next node. Okay, so this is what happens while traversing. Okay, after every node has been traversed and we come out of the while loop, what we'll do is we'll make slow dot next equals to null. Okay, which is see uh, slow dot where slow pointer reaches to the fast pointer, right? And when it reaches, it will also delete the duplicate node. And at the end, if a slow pointer points to a particular node, then it means that it has traversed everything. Okay, and the linked list has been cleared of the duplicate values. So what we'll do is just make the node where the slow pointer points, make the nodes next be nothing. Okay, which is in this case null. and then we'll just return head, because re- when you return head, it will return the whole of the linked list. Okay, so the test case has been accepted. We'll just submit. So it takes 45.55 MB. Okay, so it's O of 1. Okay, you don't make another space for keeping the values, and this is the optimal solution. Okay, so a head of slow pointer and fast pointer is the optimal approach. So this is it. Let's take the example from here itself. 1 minute. So this is the linked list node 1 with value 1, and then linked list with node value 1, another one. Okay, and the next points to 2, and this is just null. I'll just denote it like a slash mark. Okay, there's nothing to worry about. Then what our approach is doing is that there is a slow pointer. Okay, this is slow. Let me denote with S, and this is fast. Okay, what we are doing is that we'll be checking whether the slow pointer's value, okay, slope, the pointer the node at which the pointer the slow pointer points to, is if it is equal to the value of the node that is pointed by fast. Okay, if it is equal, we'll just move. Okay, and if it is not, we'll make the slow pointers next point to the fast pointers node. Okay, so let me show you. See, now uh, the slow pointers value is equal to fast pointers. What we'll do is we'll just move this. Okay, sorry, we'll just move this. Okay, we'll just move the fast pointer to here. Now we'll check again, and we'll see whether they're equal or not, and they are not equal. So what we'll do is we will change the next of the slow pointer and point it to here. Okay, and then what we'll do is just make the slow pointer, sorry, make the slow pointer go to the fast pointer's position. Now we have kept a condition in while loop that fast should not be null. Now after this thing happened, yeah, after the condition of slow value is not equal to fast value has been satisfied, we will what we'll do is just we will make the fast pointer go to the next node, which is there is no next node, so it points to null. Okay, the fast pointer points to null. Now since the fast pointer's value is null, we'll just stop the while loop. Then what we'll do is we will point uh, the slows next to null, which is already null. There is no need to do this. Okay, there is no need of that step because it is already null. Now what we'll do is we'll just return the uh, what we'll just return the head, which is pointed by this. Now you might ask what happened to this. Well, it is not pointed by anything, it just this node just points to another node. There is nothing to point this node, so automatically it becomes deleted. Since there is nothing to point to that node, it just means that it does simply does not exist. Okay, so the ultimate linked list we'll be getting is, one minute, is this. Okay, and this is still being pointed by slow pointer, and this by the head pointer, and fast pointer becomes null. So that's the dry run.